So the regular equations that we usually solve in middle school are equations like the one on the left. Now these are kind of called linear equations. They're called linear because we only have x to the exponent 1, so there's only x's here. And your usual trick is to maybe expand anything that you can see there, and then you kind of balance on both sides. So we've got subtract maybe 2x from both sides. So this is x plus 2 is equal to negative 12. Then maybe add 12 to both sides, x equals to 14. That's a nice easy way of solving equations. Over here on the right hand side, however, we have what's called a quadratic equation. Now a quadratic has an x squared in the equation. When we try and solve these types of equations, it's very hard to kind of do the balancing, because what do we do? Do we balance this way? How do we actually get the x squared and the 3x together? Is this a method here? Do we divide both sides by x? If we do, what happens here? So the clear thing is that we can't actually gather the x's together. On this side, 3x and 2x, we can put them together and collect like terms, but here we've got x squareds and x's, we can't gather like terms. So this actually calls for a completely different method to solving equations. So this is the big step up, usually from middle school to high school, that we actually deal with equations that are very hard to solve by just using the balancing method. So in order to solve these types of equations, we have to think of something else to use. So before we actually get into that particular technique, let me just ask a simple question. Here's an equation that we're going to try and solve. So again, I can see x in one place only here, so there's no x squared. It's not a quadratic, okay? And if you just pause the video and try and solve that. And so here's what many of you will have done. You will have expanded 3x minus 6 equals 0, 3x equals to 6, therefore x equals to 2, which is correct. But there's an alternative way of doing this, and if I show you the alternative way, this is the key to solving quadratics. Because now I'm going to do this. 3 times by something equals to 0. Now if you're left with that statement, can you see what the box has to be? The box has to be equal to 0. It just makes common sense, doesn't it? So, but what is in the box? In the box is x minus 2. So how do we make x minus 2 equal to 0? We make x equals to 2. So in this case, we didn't actually have to expand the bracket to be able to solve the equation. So let's think about that again. Let me give you a couple more questions to try. What if I had 7x plus 3 equals 0 and x plus 24 times by 4 equals to 0. Here you can see that 7 times by something equals 0, so the thing must be 0. Therefore x plus 3 equals 0, x must equal to negative 3. Now you can check that by expanding the bracket and solving it your usual way. And over here, can you see I can write down instantly x equals to negative 24. Now, how far does this go? Well, what if I had bracket times by bracket equals to 0? So can I see that what if I made this bracket equals to 0? That would mean I make x equals to negative 3. Let's just test it. If x equals to negative 3, what we're going to do is we are going to substitute negative 3 here and negative 3 here and see if it works. So negative 3 plus 3 times by negative 3 minus 3 equals to 0. 0 times by negative 6 equals to 0. That works. But we could say, or we could make this bracket x minus 3 equal to 0, in which case x equals to 3. So we seem to have two solutions, x equals negative 3 or x equals positive 3. Let's just do one more exercise, one more example, sorry. 2x minus 5 x plus 3 equals to 0. So either we have to make 2x minus 5 equals to 0, or we make x plus 3 equal to 0, in which case here x equals to negative 3. Now let's test x equals to negative 3 back into our equation. 2, negative 3 minus 5 is in the first bracket, and negative 3 plus 3 in the second bracket. 2 times negative 3 is negative 6, minus 5 into negative 3 plus 3 is 0. So it doesn't matter that this bracket becomes negative 11, because negative 11 times 0 is 0. So x equals negative 3 is one solution. Can you see the solution? We make 2x minus 5 equal to 0, therefore 2x equals to 5, x equals to 5 over 2. We have two solutions. So where's all this leading? Well, if we take that last equation, 2x minus 5, into x plus 3 equals to 0, if we expand the left-hand side, now expanding, you've got a variety of methods available to you. I've got the FOIL method, which is this method. I've got a structured FOIL method where it's 2x multiplied by the second bracket, and it's negative 5 times the second bracket equals 0. I've also got the grid method. Here's 2x and here's negative 5. Here's x and here's 3. So in here 2x squared, negative 5x, 6x and minus 15. And when I add all those pieces together, I've got 2x squared minus 5x plus 6x minus 15 equals 0. So 2x squared plus x minus 15 equals to 0. So now we get to the point of this video. If I have an equation 2x squared plus x minus 15 equals 0, one of the key methods I can use to solve it is by putting this and rewriting it into factorized form. Remember, factors are things that multiply together. So if I can get this into 2x minus 5 times by x plus 3, so that's an equivalent form, then I can go and solve this quadratic equation by either making the first factor equal to 0 or by making the second factor equal to 0, and therefore I get x equals to 5 over 2 or x equals to negative 3. And this is the key method by which we try and solve quadratic equations. It's not the only method, but it's one of the key methods, and so most of the unit will be focused on trying to solve quadratic equations.